Tom Kingham, Vice President of Engineering and Utilities Europe at CyrusOne. Thank you for taking the time to speak with us today. We're here in the run-up to Data Center Expo Europe in Amsterdam, where Tom will be speaking, and we're here to discuss a few industry trends and how CyrusOne is addressing them. But before we go into that, Tom, can you just tell us a little bit about you, your career to date, and your current role at CyrusOne?
Yeah, thanks, James. Great to join you today. So I'm Tom Kingham, as you've introduced me. I'm looking after engineering and utilities for CyrusOne across Europe. I've been working in data centers now since the beginning of 2007, where I started out as a design consultant for Red Engineering back in the day, and now find myself here at CyrusOne. Very privileged to have worked in data centers for that whole time. So it's been really interesting to see the change from what we were doing back in 2007 to what we're doing now, and even seeing some of those facilities that I worked on back then, how their sort of lives have evolved over the last 18 years.
Okay, fantastic. Thank you for that. Let's start with something sort of relatively newsworthy, if we may. Last month, the UK government published a report with Europe Economics on the impact of growth of data centers on energy consumption.
Mm.
With AI driving data growth, energy use is often a concern. How is CyrusOne addressing the energy requirements of modern data centers, especially in the light of these recent government reports?
I think it's incumbent upon us to use that energy wisely. So we're putting a lot of effort into making sure that these facilities are designed with energy efficiency at heart. It's not necessarily just the access to the energy that's a concern. It's also the cost of it. AI is an incredibly energy intensive process, if you will, and we need to make sure that we make the most out of the energy that's coming to the facility. And when we consider how difficult it is to get the power supply in the first place, that gives even more incentive on us to make sure that everything that's coming into the building is being used in the most efficient, effective way possible, so that we can maximize the output being the product of AI or cloud computing or whatever else it is that's happening inside that data center. There's been a lot of change over the years in people's view on what is the most energy efficient type of data center, because as you've alluded to with the news recently around water consumption in data centers. Well, back in 2007, 2008, there was quite a strong desire to reduce electricity consumption by using water for cooling systems. But our data centers back then were only a few megawatts in size. They're not the hundreds of megawatts in size they are now. So it was quite appropriate for us to try and reduce our energy consumption back then by using water. From CyrusOne's perspective, we've changed our view over the years that really would rather not place any burden on local water supplies, particularly on potable or drinking water supplies, and have therefore had to forego some of the energy saving as a result of it, but in its place, ensuring that we've got a robust procurement for our energy that is zero carbon. So we want to make sure that where we are having to buy energy, we're buying it as green as we possibly can. Acknowledging that if we were to use water for some of our cooling systems, we'd probably need less energy. But our feeling is that where these facilities are now so large, it is more appropriate to use energy than it is to use water. I think that might change a little bit as we move into more industrial locations for data centers. I mean, that's really playing on what Jensen Huang keeps telling us, that these are AI factories as opposed to data centers. So factories should probably be located where factories are, or historic factories have been located. And those tended to use quite a lot of water for process purposes, but that water would come from rivers or other water sources. So we're certainly investigating the potential for reducing our energy by using water, but in locations where we're not going to have a net impact on water consumption in that area, and certainly not for drinking water.
Okay, great, thank you. So that's the industry perspective, I suppose. But the public understanding of these issues, public discussion often focuses on the environmental impact of data centers, water and energy uses, as you've mentioned, Tom. How does the industry improve understanding in this area, and what steps is CyrusOne taking?
It's a really difficult one for our industry to properly wrap its head around, because we've been so used to, due to customer demand, really, being quite secretive. People have not necessarily understood that the cloud sits in a warehouse somewhere. And I think as the prevalence of AI and cloud computing, it sort of hits all of us as general consumers, people are asking very good questions like, do we really need it? And do we believe that the energy and resources that are going into these facilities are being procured in the best possible way without it being impactful on us as individual consumers? And I think that's been something that the data center industry historically hasn't been very good at explaining. But what we're seeing now through our development processes, as we find new sites and we want to develop in certain locations, we are being very much more transparent about where our energy is going to come from, how are we going to impact on the local community, and how might we be actually advantageous to that community. So I look at a project we have in Frankfurt at the moment, where the data center will provide all of the heat to the business park. So everybody building their business on that park will be heated by a data center, and I think that's the sort of example where, as an industry, we really want to do the right thing, but when a data center pops up where there isn't that situation where you can offload your heat to a local network because that network doesn't exist, it's a tricky one. So we're now looking for those locations where we can be a much better community member, if you will, where we can provide heat to other local consumers. We're looking at things like local generation schemes, where, of course, the data center needs power and needs energy, but so do other people in those locations. And if you're in a constrained location where transmission upgrades are many, many years behind where the local house builders have demand, or other businesses need more energy, then that's where we're really hoping that things like our local generation scheme will be relevant. It's not just for the data center, it should be for everyone in the vicinity.
Great, thank you. Another area in which AI is making its presence felt, if you will, is in data center design itself. How is AI influencing data center design, Tom? And can you share any insight on some of the innovations that CyrusOne is introducing to meet customer needs?
Yeah, so we're in a fairly early stage of AI at the moment, but it's growing very fast, and therefore we're in a bit of a flux from a design point of view, because we know what we need to do from the more traditional, even though that's only a few years old, on the cloud side of things, with air-cooled servers and the typical data center design. But we need to be able to modularize that so that we can take the same sort of equipment principles and apply it to an artificial intelligence data center, or more particularly a water-cooled GPU type environment. The difference being that those AI factories have a much higher density, where the power to a rack will be in the hundreds of kilowatts per rack, as opposed to the cloud data center, where we were at 10, 15, maybe 20 kilowatts a rack. So what we want to try and do is use the same component parts, just put more of them into the same space, and that's broadly what our Intelliscale offering is. That we are not trying to completely rethink AI. What we're trying to do is get ourselves to that modular element where we just deploy more of it, depending on what the use case is for the customer in these data centers. So one of the primary things that we're quite excited about is with artificial intelligence comes the GPUs, which are typically being liquid cooled because the density is much higher. We can operate at a much higher temperature within the data center. And that becomes interesting because we need less cooling to be able to make that work. Therefore, we need less energy. And if we were using water, we would need less water. So there's some really good developments ahead for the data center industry to reduce the impact that we're having. It's just that the demand is so significant that the overall amount of energy we will use will grow. But hopefully we're becoming much more efficient with it as that growth happens.
Great, thank you. You mentioned Intelliscale there. Can you go a little deeper and explain the types of high performance workloads Intelliscale supports and how it delivers on those requirements?
So Intelliscale is fundamentally our flexibility in being able to meet whatever the customer demand is with broadly the same equipment that we would deploy at an infrastructure level. Because our challenge as a data center developer is making sure that what we think we should build is what customers actually want by the time that construction project is complete. If I look at our European portfolio, some of our developments may take 4 or 5 years from conception through to going live. That's not necessarily a data center problem per se. That's more making sure that we've addressed the community requirements for the data center, and the planning process is procuring the power, because now we need a lot more power. So in that time frame, a huge amount happens, and we have, again, Jensen saying that they're targeting refresh of GPUs every 9 months or so. Now that's a lot for us to be able to keep up with, particularly when you look at something like a generator takes a year to go live, as it were, from point of order. So we had to come up with a way of being able to respond in a fast way to customer demands changing, without us necessarily having to fundamentally change the backbone of the equipment that's going in. So what you see from Intelliscale is that modular approach to a data center. We can build the building, but we have the flexibility to put more or less power and cooling lineups in to support that.
Okay, thank you. And in terms of scalability, one of the aspects of Intelliscale, the ability for customers to scale workloads both up and down, how important is that ability for customers, and what was involved in enabling that capability?
I suppose with that one, we don't necessarily know yet, but we want to know that we've got the ability to do it. We can clearly see from history that the scale is likely to only go up. So this is more about, we can add things, but if you can add them, then by their very nature, you should be able to remove them again. So we're addressing something that we're not completely familiar with yet, because I don't think anybody is. But we want to make sure that we don't end up with lots of equipment in say 5-10 years time that isn't necessary, that we could redeploy it somewhere else, or we could optimize the design of the facility to suit whatever the workload is in 5 or 10 years time. And that's been quite an important lesson for us to have learned over the years, is that we might think we know what's going to happen, but it's been pretty evident that it changes fast, and the best thing to do is maintain some flexibility so that our customers can respond to that growth, or indeed shrink if needs be.
Okay, interesting. Thank you. We are at an interesting sort of tipping point here generally, and it does relate to what we've been discussing previously. The industry is trying to solve the problem of maximizing performance with AI, but doing it sustainably. You've spoken about the data center design previously, Tom, but tell me about CyrusOne's modular design and how it supports AI demands while advancing sustainability from both a company and a customer perspective.
Yeah, so it's rooted in the modularity element, so that we have um, a lineup, as it were, that is that deals with power and cooling in a block, so that we can deploy as many blocks as we want to be able to satisfy the demand of the data center. And as I was talking about previously, the ability to then add more even once the facility is live without impacting on operation. And I think that's something that is really important as we are entering this. I suppose it's not really new anymore, but it feels still pretty new, and there's a lot more to learn. Maintaining that flexibility is absolutely key. And as we grow with our customers, we're learning more and more about how these facilities will actually operate, and therefore how our design needs to adjust to accommodate this. So I don't know that we've got all of the answers yet, but we're trying to set ourselves up that we maintain that flexibility, so that when something comes out of the woodwork later on, we're able to flex and handle that.
Great, thank you. You're going to be speaking at Data Center Expo at a panel session entitled Exploring Innovations and Emerging Trends Driving the Future of Data Centers. Give us an idea, without giving too much away, I suppose, give us an idea of what topics you'll be focusing on at the event and sort of what you hope attendees are going to take away from your session.
So we've got a really good mix of people on our panel, which from our early discussions has proved to be really quite exciting. We've got opinions from people who are building AI data centers, not for the customers that we all are very familiar with, but for the new wave of AI customers. And I think that's quite exciting to see what's happening on that front. You've got the manufacturers who are able to talk about what's the development in the products that are maybe 3 or 4 years out from being released, and how are they flexing to suit what we're seeing coming down the line from an AI point of view. And then from our perspective as a third party operator, where we're building both for the hyperscalers but also for our co-location customers, the enterprise customers, and how do we handle being able to be all things to all people on that spectrum. So I think there's some really, really interesting perspectives that come from absolute both ends of the spectrum, but and across the manufacturing side of the industry as well.
And finally, Tom, looking ahead, this is the crystal ball question, if you like. What trends do you see shaping data center design and operations over the next 12 months?
Clearly, liquid cooling is here to stay, and I'm really pleased that we've got to that point, because it is a much more energy efficient way of removing heat. Density will continue to increase. I think I have concerns on how will we actually get power to these racks, and not just have one every 20 or 30 square meters spread out across a data hall. How do we marry what the network requirements are of AI to how do you actually distribute the power and cooling to the racks when they're next to each other? So I think what's really exciting is that there's quite a lot more innovation to come. There's the rapid increase in density and the change in the demand from data centers to support AI and who knows what next. I think gives us a really good exciting few years ahead for the R&D departments at our manufacturing partners, us from a point of view of what is it that we need to be designing for over the next few years. So I think from an industry perspective, this is a really exciting time, and I certainly look forward to the next few years of change being constant.